Okay, today we're going to learn or look at section 1.6, more equations and applications. So, solving a radical equation is what we're looking for here. First, we isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. Raise each side of the equation to a power equal to the index of the radical. Solve the resulting equation. If the equation still has a radical, repeat steps 1 and 2. And check the potential solutions in the original equation and write the solution set. So let's run through the skill practice on these. And we'll start out with skill practice 1. And it's simply solve the equation. 25y cubed plus 10, or 100, sorry, y squared minus y minus 4. Okay, what we can do is we can group this. Group these two together and group these two together. So here I have 25y times y squared. That's this right here. Plus 25 times 4y. If you distribute this, you get this. So we're good. Now here, not 4. Actually, we can factor out. Let me redo that. Because we can factor out 25y squared. Y plus 4. There we go. And here I can factor out -1 and get y plus 4. And this equals 0. So what I have here is 25y squared minus 1 times y plus 4 equals 0. Now I can factor this as well, since it's the difference of two perfect squares. What is this? 5, the square root of 25, which is 5, square root of y squared, which is y, plus the square root of 1, which is 1, times 5y minus 1 times y plus 4 equals 0. So this means that 5y plus 1 equals 0, or 5y minus 1 equals 0, or y plus 4 equals 0. So here we have 5y equals -1, y equals -1/5. Here we have 5y equals 1, y equals 1/5. And here we have y equals -4. Looking in our original equation, all of these will work. I'm not going to do the actual checking. I'll get all the way down here. There we are. So my solution set is -1/5, 1/5, -4. The main thing you have to worry about when checking your answers is if there is a variable in a denominator or if there's a radical. You have to take that into account. Typically, it's not an issue. So next up, we have skill practice 2, which is w to the 4th equals 27w. Now we can divide both sides by w and get w to the 3rd equals 27. Then we could take the cube root of both sides. This is w and this is 3. And there we go. 3 to the 4th is 81. 27 times 3 is 81. So our solution set is 3. Okay, now we're going to get into the rational expressions or equations. So looking at skill practice 3, we have 3x over x minus 5 equals 2 over x plus 1 plus 2x plus 40 over x squared minus 4x minus 5. So the first thing we need to do is find the least common denominator. So what I want to do is factor this, and this factors to x minus 5 times x plus 1, which works out well, because here I have x minus 5, here I have x plus 1, and here I have both of them. So this is my least common denominator. So if I take this and multiply both sides by it, here the x minus 5's cancel out, and I get 3x times x plus 1. Here the x plus 1's cancel out, and I get 2 times x minus 5, and that is an x squared. And here they both cancel out, so I get plus 2x plus 40. So now let's do our distribution here. 3x times x is 3x squared. 3x times 1 is plus 3x. We have 2 times x, which is 2x, minus 2 times 5, which is 10, plus, and this is squared, 2x squared plus 40. So let's bring everything over here. So I have 2x squared here. I'm going to subtract that from both sides and get simply x squared. I have 3x and I have 2x here. Subtracting 2x from both sides, I get negative or plus x. And here I have negative 10 and 40, which gives me 30. When I subtract it, minus 30 equals 0. And factoring, I get x plus 6 x minus 5. So x plus 6 equals 0, or x minus 5 equals 0. X equals negative 6, or x equals 5. Now, looking at negative 6, we go back up to our original equation, and it'll work. So negative 6 is part of the solution. However, looking at 5, I have a problem here. I get division by 0. So 5 is not part of the solution. My solution set is simply negative 6. Okay, so now let's look at some application problems. We have a fishing boat can travel 60 kilometers with a 2.5 kilometer per hour current, and 2 hours less time than it can travel 60 kilometers against the current. So some speed x plus 2.5, that would be the speed. Let's write this out in a table form. We have with, current, and against current. Oh, we have our distance. That's what I was missing. Our distance is 60 kilometers. Our rate with the current is x plus 2.5. Our rate against the current is x minus 2.5. And our time is the distance divided by the rate. Okay. So now the difference between these two (60 over x minus 2.5 minus 60 over x plus 2.5) is going to equal to 2 hours going to equal 2 hours less. So let's do that the other way. So if I take the time traveled, that's going to take the longest, against the time against the current, and subtract the time with the current, and get the difference of 2. So again, finding my least common denominator, it is x minus 2.5 from here, and x plus 2.5 here. And just to make things easier on us, x squared, what is that, minus 6.25. That's what that comes out to be. We'll need that in a moment. So here I'm going to have 60 times x plus 2.5 minus 60 times x minus 2.5 equals 2 times both of them, x squared minus 6.25. So this is 60x, and this becomes plus 150 minus 60x plus 150 equals 2x squared minus 12.5. Okay, well this and this cancels out. So we end up with 300 equals 2x squared minus 12.5. Add 12.5, I got 312.5 equals 2x squared. Divide by 2, and I get 156.25 equals x squared. And then I need the square root of square root 156.25. So x would be plus or minus 12.5. We're talking speed, so it would only be plus 12.5 kilometers per hour. Okay, so real quickly, we'll talk a little bit about absolute value. K is a positive real. Absolute value of u equals k is the same as u equals k or u equals negative k. Absolute value of u equals 0 means that u equals 0. Absolute value of u equals negative k no solution. You always get a positive outside the absolute value. And the last thing to keep in mind is absolute value of u equals absolute value of w. And u equals w or u equals negative w. So let's look at skill practice 5 here. I'm just going to do A. 5 times the absolute value of 2 minus 4r equals 50. Our first step, I would divide by 5. The absolute value of 2 minus 4r equals 10. So 2 minus 4r equals 10, or 2 minus 4r equals negative 10. And now we just solve this. Subtract 2 and we get negative 4r equals 8, r equals negative 2. Subtract 2 and we get negative 4r equals negative 12, r equals 6. All right, no, 3. So putting negative 2 in here, we have 2 minus 4 times negative 2 is 2, plus 8 is 10. Absolute value of 10 is 10. 5 times 10 is 50. Plugging 3 in here, I have 2 minus 4 times 3, which is 12. 2 minus 12 is negative 10. Absolute value of negative 10 is 10. 5 times 10 is 50. So my solution set is negative 2 and 3. Okay, let's look at another one. Let's look at one that has both. So I'm going to go skill practice 6. And again, I'll do A. Absolute value of 3x minus 4 is equal to the absolute value of 2x plus 1. So this means that 3x minus 4 equals 2x plus 1, or 3x minus 4 equals the negative of 2x plus 1. So let's start with the easy one over here. Subtract 2x from both sides, we get x. Add the 4 to the other side, and we get equals 5. Over here, we need to distribute this negative, so I have 3x minus 4 equals negative 2x minus 1. Add 2x to both sides, we get 5x. Add 4 to both sides, and we get equals 3, and x equals 3/5. So looking at the solutions, using 5, we get 3 times 5 is 15 minus 4 is 11. Absolute value of 11 is 11. 2 times 5 is 5, plus 1 is 11. 11 equals 11. So this is a valid answer. Maybe let's work a little on the side here. Absolute value of 3 times 3/5 minus 4, which I'm going to go ahead and call minus 25th, equal to absolute value of 2 times 3/5 plus 5/5. So keeping this, I have 9/5 minus 25th. Absolute value equals absolute value of 6/5 plus 5/5. So here I have the absolute value of negative 11/5, and here I have the absolute value of 11/5, which are the same. So my solution set again is 5 and 3/5. Okay, now we're going to look at rational equations. We'll look at skill practice 7, which says solve the equation. The square root of t plus 7 equals t minus 5. Now, if we go back to here, you want to isolate the radical. It already is. Raise each side to the equation of the index. and solve the resulting equation. So we've got the radical isolated. It's square root, so we take both sides to the second power. We square both sides. Here I get t plus 7. Here I get t squared minus 10t plus 25. So let's go ahead and move everything over. So this is t squared. Subtract t from both sides, minus 11t. Subtract 7 from both sides, plus 18, and that equals 0. Now factoring, looks like 2 and 9, and they're both negative. So I have t minus 2 times t minus 9 equals 0. T minus 2 equals 0, or t minus 9 equals 0. T equals 2, or t equals 9. So going back to our original equation, we have square root of 2 plus 7 equals 2 minus 5. This is square root of 9, negative 3. Okay. Plus or minus 3 equals negative 3. Negative 3 equals negative 3, but positive 3 does not, so we cannot accept that answer. How about 9? Now we get the square root of 9 plus 7 equals 9 minus 5. Square root of 16 equals, actually, that's not the reason why. We're sticking only with positives at this point. 4, and this is 4 equals 4, and that checks. So our solution set is 9. I don't picture myself putting a question with something like this, because technically you could say it's right. It would be too easy to mess up. Or if there is one like that, I will accept both answers. Okay. And now let's look at one with radicals on both sides. We have 1 plus the square root of n plus 4 equals the square root of 3n plus 1. Now here we have a problem. We have one radical on each side, but we have this. So if we square both sides, and I'm going to go ahead and rewrite this. So we just squared both sides. Well, this works out wonderful. 3x plus 1. This, however, when you square the first one, 1, multiply the first time the second, and then multiply by 2, so we have plus 2 times square root of n plus 4, and then you square the second. This is plus n plus 4. So now we have a radical here. We need to isolate it. So I have 1 and 4 is 5. I'm going to subtract 5, and I have an n. This is supposed to have been n's. So subtracting the n, I get 2n. Subtracting the 5, I get minus 4. That leaves me with 2 times the square root of n plus 4. Now again, we want to isolate the radical, so we need to get rid of this 2 as well. Divide everything by 2 and get the square root of n plus 4 equals n minus 2. So again, square root of n plus 4, n minus 2. Square both sides. Here I get n plus 4. Here I get n squared minus 4n plus 4. Okay. So if I subtract, I get n squared. Subtract n, I get minus 5n. Subtract 4, and I get 0. So now I'm looking at n squared minus 5n equals 0. I'm looking at n times n minus 5 equals 0. So either n equals 0 or n minus 5 equals 0, n equals 5. So what happens when n is 0? I get 0 plus 2 or plus 4. Square root of 4 is 2 plus 1 is 3. Here I get 0 plus 1 is 1. So this is not a valid answer. Let's look at 5. Here I get 5 plus 4 is 9. The square root is 3. So I get 4. Here I have 3 times 5 is 15 plus 1 is 16. Square root of 16 is 4. So this is our solution set is 5. So with radicals, with variables in the denominator, you definitely need to check. Now let's look at skill practice number 9. This one's a little harder. First up, I have 2 times x minus 3 to the 3/4 equals 54. Well, the first thing I'm going to do is divide by 2. I have x minus 3 to the 3/4 is equal to 27. Now, there's a couple ways we can do this. One way is to take everything to the 4/3 power. So this gives me x minus 3. Now, 27 to the 4/3. What is this? This is 27, the cube root of 27 to the 4. Or the cube root of 27 to the 4th, which is 3 to the 4th, which is 81. In this case, x equals 84. So we could break this down initially. As x minus 3, we'll take the 4th root of x minus 3 to the 3rd equals 27. Oh, that's not what I want. Yeah, that's what this is. So now if I take the cube root of that, take the cube root of both sides, this becomes 3, and this becomes the 4th root of x minus 3. Okay, then I take both of these to the 4th. This becomes 81, and this is simply x minus 3, and x equals 84 again. So either of those methods would work. I think, yeah, the book shows it going this way. Okay, so now we got skill practice 10. We have x squared minus 6 squared plus 33 times x squared minus 6 plus 62 equals 0. Now, we could go ahead and distribute this, or however you want to put it. Distribute the 33 here. Square this. Combine the like terms. But it's going to look kind of nasty. Plus, we'll have a fourth degree term. So there's a neat thing about mathematics. A variable. In this case, we're looking at x. We don't know what it is, but it can be anything for the time being. So why can't I just create a new variable? And we'll call it u. And I'm going to let u equal to x squared minus 6. I don't know what x squared minus 6 is. I don't know what u is, but I know it's equal to x squared minus 6. So what that does for me is this becomes u squared plus 33u plus 62 equals 0. Okay. And it looks like my factors are 2 and 31. So I have u plus 2 times u plus 31 equals 0. So u plus 2 equals 0, or u plus 31 equals 0. U equals negative 2, or u equals negative 31. So that means x squared minus 6 equals negative 2. If I add 2 to both sides, I get x squared minus 4 equals 0. Gives me x minus 2 times x plus 2 equals 0. X equals 2, or x equals negative 2. Looking at my original equation, that's not going to affect anything. I can check it, and since x is squared is going to be the same for negative or positive, so I have 4 minus 6, negative 2 squared 4. Now I have 4 minus 2, which is negative 2 times 33, 66, negative 66 minus 4, negative 62 plus. So these two answers will work. Now let's look at this 31. X squared minus 6 equals 31. That gives us x squared, or negative 31. This gives us x squared plus 25 equals 0. And here's the weird thing. Now we go back to accepting I. So if we rewrite this as x squared equals negative 25 and take the square root of both sides, we get x equals plus or minus the square root of negative 25, which is plus or minus 5i. And it's accepting those. Again, I don't intend on putting any answers, any questions with the solution of I. If you come across one on an exam, simply put does not exist. Now the homework could very possibly have it. So this makes my solutions 2, negative 2, 5i, negative 5i. Again, I do not like that the answer came out to that, but fortunately after chapter 1 there won't be any. So let's look at one more. So we have 2 times t to the 2/3 equals 15 minus 7 times t to the 1/3. So it looks like I can let u equal t to the 1/3. Now this becomes 2u squared equals 15 minus 7u. Go ahead and bring everything over. 2u squared plus 7u minus 15 equals 0. Here I don't see the factors readily, so I'm going to use my quadratic formula. U equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now the negative of b, which is 7, plus or minus 7 squared minus 4 times a, which is 2, times c, which is negative 15, all over 2 times 2. Then we have negative 7 plus or minus the square root of 49 plus 120 over 4, which is negative 7 plus or minus the square root of 169 over 4. I believe that's 13, isn't it? Negative 7 plus or minus 13 over 4. Negative 7 minus 13 is negative 20 over 4, which is negative 5. Negative 7 plus 13 is 6 over 4, which is 3 halves. Okay. And I've lost my place here. Here we are. So u is equal to negative 5 or 3 halves. So let's start with negative 5 equals t to the 1/3. Cube both sides, and we get t equals negative 125. And then we have 3 halves equals t to the 1/3. Cube both sides. 3 cubed is 27. 2 cubed is 8. And those match up. So I'm looking at the solution set, negative 125 and 27 over 8. Oops, that. On exams, I know the book goes through with set notation. That's what it's looking for. That's probably what the homework will be looking for. I'm a little less strict. If you get to this and you signify that that's an answer by circling it, highlighting it, putting a square around it, something that shows me it's the answer, I'll give you credit. I'm not requiring that you necessarily put it in the set notation. And that's all for this section. Have a good day, and we will see you next time.